My name is Furkan, co-founder and CTO of Bebo, and today I'm going to talk to you guys about machine learning your 8-year-old would be proud of. 8-year-olds don't think about machine learning, and so, to think about what an 8-year-old would appreciate, I think about what life was like when I was 8 and kind of what I was thinking about and what I was doing. For me, growing up, I spent a lot of time on sports. Sports was a big part of my life. Playing sports, watching sports, football, basketball, baseball, just kind of all around. That was a big part of my life growing up. I played Little League, I played football, just recreationally all over the place. And it was exciting, it was fun, it was something for me to do. Even though I wasn't trying to go to the NBA, I'm not a huge guy, I'm not athletic like that, but it was fun. With today's generation, though, it's a little bit different. They play video games. It's a big part of their life and kind of what they want to do. They watch YouTube, Twitch. That's what they spend their energy on, and a lot of it. Kind of like I watched sports growing up. I watched Jerry Rice, they're watching Ninja. And so this analogy for me kind of made a lot of sense. And growing up, I played a lot of sports recreationally. This was something that, ever since I was 5, I played Little League, soccer, football, baseball, high school, college intramurals, and in every aspect of it, it was just about kind of having that. And today, there's no way for kids to play esports recreationally. This doesn't exist. Esports is actually really big and hyped and has grown a lot, but it's focused on the pros, the people who are at the top 1,000 players of every game. And so, with this analogy, Bebo is born. And what is Bebo? Bebo is esports for every gamer. So we don't focus on the pros. We wanted to create recreational leagues for kind of every tier of gamer. And you think about Little League baseball, we want to create Little League for esports. High school baseball, high school football, we want to create high school esports. And just recreate that feeling of recreational sports. And what is that feeling? It's friendly, it's social, it's something that you do not because you're trying to go pro, but because you're excited, you're energized about it, and it's something that really interests you. And today, kind of kids and a lot of people play video games for the fun of it, the casual aspect, but adding some social layers in between is kind of part of our mission. And so, as an entrepreneur and engineer, for me, I always think about, well, how do we build this? What do we need to do to kind of create this item? This is a new behavior, it doesn't exist. And so how do we kind of put this all together? And really, whenever you're thinking about building anything, it's always, let's start with the users, right? And so the users in this case are the people who play the games, the gamers, the players. And they have certain needs, and how do we kind of take that into account, and what do we need to do to kind of create that scenario for them? And so whenever you're creating a new behavior, you want to look at, well, what exists that's like this? And organized sports, like I was mentioning, is a very similar analogy to kind of what we want to create in gaming and esports. And what do organized sports provide? They provide a referee, a way to kind of follow the rules of the game, not cheat, have some kind of organization around it, create rankings, leaderboards, scoreboards, standings, basically something where you can compete and kind of show, hey, I'm on top, or I'm in the middle, I'm on the bottom, some way to climb the ladder. And the last part of it is the scoreboard. When you shoot a 3 in basketball, you look at the score, it goes up. That's that kind of feedback you want. That's why you play the sports, and at the end of the game, you get a win, and that's the second part of the scoreboard. And so taking this framework, we wanted to create these same kind of structures within recreational esports. And today we'll focus on the scoreboard side of it and really the automation around it. And this was one of the biggest challenges that we had in coming up with our product was how do we create this automated way to showcase the score? How does that happen? And the challenges were really around the game APIs. Normally when you're building a product and you're thinking about, hey, how do we get this external piece of data? How do we put it into our app? How do we combine it all together? You use APIs. Okay, we'll pull Instagram, we'll pull Facebook. With games, the APIs have a ton of problems. Mostly they don't exist. So you can't get data if they don't exist, and you don't have it. So, okay, that's tricky. And when they exist, they're not real time. You get it later. You might get it in an hour or after the game. Well, if I shoot a 3 and we run around back and forth on a basketball court, but we don't know the score, it'd be kind of weird, right? And so that was a huge problem for us. And sometimes when they exist, you're missing stuff. You might know who's playing in the game or, what your team is, but you might not know the score. You might not know the map you're on. You might not know anything that's relevant to kind of creating this competition. And lastly, each game is different. And when you look at how many games people play, there's about 25 of the top games. That's what majority of gamers play. And 25 different APIs, if they existed and they were all real time, and they'd all be in different formats. You got JSON format, you got XML, you got somebody looking at this. And so these were kind of the challenges that we approached with the scoreboard automation. What's interesting, though, is as players, you see everything. You're playing the game, you have all the information, and the game HUD, the heads-up display, shows you actually all of the information. It shows you things like your health. When you take some damage, when your shield goes down, you know that. You can see your inventory, the weapons you're using, what's equipped, how many materials you have, kind of all the relevant items that you need to play the game. And lastly, the stats. How much time left in the game? How many people left? What are, where am I in the ranking? And so as a player, you see all of this. You're interacting with all of this, and you get a great experience playing the game. But as a developer, we don't have access to this information. And so this is kind of where we asked ourselves kind of a simple question. What if we use computer vision to create an API for every game? We can basically use this technology that's gotten a lot better in the last couple of years to get ourselves in and get the information that we want. And why use computer vision? What are the advantages of using it, and how do we kind of use that? And so games are very predictable. They look mostly the same. They don't really change that often, and they're very, very easy to train. It's very different than the self-driving car problem where you have a random object coming in front of a car. It could be a person, it could be a dog, it could be a bag or a reflection. Games aren't like that. They look the same. Once in a while they update, but very easy to train and very predictable. We can detect everything the user can see. And so when you're playing basketball and you shoot, you have this referee on the side, you have a scorekeeper, they press this button, the score goes up. Well, that's where our software would come in, and that's actually what we're able to do. And whatever you can see and you interact with, that's what we want to interact with, and that's what we want to kind of capture. And lastly, people play games all around the world in every resolution and on widescreen displays and stretch displays and every language, and computer vision or machine learning can help us kind of take all of that variance into account and basically take that in. So we used this concept around computer vision to say, this is why we want to go down this path. And when you're thinking about using computer vision, you kind of say, okay, well, how do we do this? What's the process? And it's a couple of steps. First, you got to get the data. The data is the key part of kind of any machine learning. You need to classify and label the data. You need to then train your model and kind of get everything set up. And then you got to do the fun step of testing and deploying and getting that out there. And so this is kind of what we're going to go over today, is how we at Bebo use computer vision in these steps to kind of accomplish the task of creating recreational esports, and really around the scoreboard and the automation of it. And so let's get the data. In our case, this is going to be video. So deep learning is fueled with data. It's basically, that's the gasoline for it. You're driving a car, you pour some gas in it. Unless you're driving a Tesla, then just plug it into the wall. But with deep learning, data is the key. And really, the more the better. It's not like you're going to overflow your tank, really. What's going to end up happening is you give the machine more information. Once you get to 100% accuracy, that's when you stop. But you really want to try to get as much of it as possible and get it into the machines and teach the machine what you want it to see. And lastly, labeling. This is the key to success. You need good data, not bad data. You need relevant data, data that the machine can say, okay, this is this, this is that, and we're able to kind of do that. And so when we're thinking about building this, we say, okay, let's go get this data. How do we get this game information? How do we train the machines to build a model so that we can create these APIs so the gamers can have fun and do that? Whenever you're thinking about something to build, you're like, all right, what are the conditions? What are the requirements? How do I put this together? Gamers are on Windows. That's the #1 platform for gaming. So that was a condition that's in front of us. Luckily, gamers have very powerful machines with great bandwidth. I mean, they look at ping. If you have bad ping, you won't be very good at the game. You're going to lag out. You're going to lose. So they want a good machine with a good graphics card and a good processor and great bandwidth. Excellent scenario for us to kind of build what we want. Lastly, though, there's a big problem. The game takes up pretty much most of the GPU. If you play any game, you'll notice they just go to 100%. Why? The game says, oh, we'll take it all. This is all you're doing right now. So this was kind of the conditions that were set in front of us. And with that, we were like, all right, we're going to take these conditions, we're going to set up a solution, and we're going to capture the game on the client. So we're going to build a Windows app. We're going to say, cool, we'll grab the game, we'll grab the frame, we're going to put that together. We're going to actually send this video to our server, And then from there, we'll detect events on our server side using the video. What this will allow us to do is use very little resource on the client side. We won't run our models there. We'll run it on our end. And because they have great bandwidth, we know we can send a video. And that's how we'll set it up. And so this is the solution that we set aside and we ended up building. So if we look at the pipeline on the client side, what does it look like? What do you need to do? And kind of what are the requirements there? The first key requirement is capture the game frames. Without the game, we have nothing. That's the #1 task for us here. Second one is we need to encode this into video. Raw game frame is massive. It's gigabytes. It's humongous. We need to encode it, compress it, getting it into a small enough package so that we can send it to our server. And we need to stream it in real time. It would be weird if you shoot a 3 and 5 minutes later it goes up. So we need to make sure we do this in real time and we send it to our servers and we're able to process all of that instantly. And we'll look at kind of what the client-side pipeline looks like. And so you're playing a game, Fortnite. That's kind of most popular game in the world right now, so we'll start with that. And really, we want to capture this game frame, and we use a set of open source technologies to do that. So we rely on a framework called GStreamer. It's an excellent, powerful video framework that's used for a variety of purposes. You can build really complex applications or very simple ones. And we combine that with an open source project called OBS, and they have an inject capture, which allows you to inject yourself into any full screen application on Windows. And so we inject ourselves into the game using OBS, and we feed those frames into the GStreamer framework, and that allows us to kind of get that first side of the pipeline. We got access to the frame. We got what the gamer sees. Awesome. The next thing is we want to encode. And luckily, these computers are very powerful. They have these dedicated graphics cards, mostly NVIDIA. And actually, these graphics cards have a chip on there that's an encoder. And so we leverage that chip to basically encode the video into H.264 and basically use almost no resource. And then we use WebRTC to send that to the servers. And we rely on Amazon and EC2 to kind of be global around the world. We're in 13 different regions, so you want to be close to the user when you're sending video. And basically, this pipeline allows us to grab the frame, encode it, and send it up to our servers in real time. And then we look at the back end, the video server. What do you need to do for the video server to kind of process this information? Well, first, you got to receive the video. That's the task at hand. The next thing is you need to decode. And lastly, you need to extract an image from it. This is going to be the main unit that we detect from is this image. And so we decided that, most games, they show you kind of these events in 1 or 2 second granularity. We currently extract an image per second out of 30 or 60 seconds of video that are happening. And the pipeline on the server side, I'll kind of show you guys how it ended up working out. So we have this H.264 video. This is being sent to our servers. We then ingest this using a framework called GStreamer. You guys will remember that. So GStreamer is awesome. It's cross-platform. On the client side, we use it on Windows. On the server side, we use it on Linux. And it's really nice kind of as a small startup team to be able to learn one framework, not learn 10. And so it was really awesome for us to just take that, put it together, ingest using WebRTC there, and feed it to the NV decoder. And you'll notice, again, we're using NVEnc. Amazon has G3 instances. These G3 instances have the same chip on there. You can encode and decode hardware accelerated with using very little resource. And so we leverage the same kind of idea that we were doing on the client side, server side to get ourselves some performance. And lastly, we extract an image out of this decoded frame, and we basically get that ready for our computer vision machine learning engine. This image is basically split into 2 spots. So we send it to SageMaker in real time. That's for our real-time detection. And then we store every image in S3 for classification and labeling. That's kind of like the major task at hand for us is when you're creating a learning model, you want to get all this information. And S3 makes it really easy. Every region in the world, we have a bucket that these images are going into. It's really cheap and cost-effective to store millions of images a day. And you can kind of process and access that from wherever you want. And so now we have the video entering our servers. We have kind of the data coming in. It's time to classify this information and label it and get it ready for our models. And again, with anything, you have these goals. You're like trying to achieve something. With classification, we're basically looking at, we wanted to make it easy for non-engineers to label. And most of the tasks that we focus on at our startup is engineering tasks. Okay, we got to build this. We got to do that. You got to write software to do this. But sometimes you can leverage the rest of the team. And we're small. We're about 10 people. And so how do you take everybody in the company and solve technology problems? Well, you make it easy for them to do something. Well, in this case, labeling was one of the actions. Sometimes you have external data sources. The game APIs that exist that are non-real time, well, I can reference and say, hey, at this time, this kill happened. Well, awesome. We can take the image from S3 and say, hey, this API over here will combine the two, and automatic classification is there. And game logs are also very interesting. A lot of fun stuff in there. And so sometimes you can parse the logs, read through them, and create this classification. So that was the second goal that we wanted. And the last was, you need a source of truth when you're creating all of these models. And so this classification framework that we built, we really wanted to make it the source of truth for all of our training data. For the things that we wanted to train, we want to say, cool, this was this model, it came from these images, and this is how it worked. And we'll look at what the classification pipeline looked like. It all starts with S3, and S3 has this great feature where you can create events from things that are being stored or deleted from there. And so we leverage this, and so all these images are going into S3 in every single region. These S3 buckets are emitting events that go into SQS, and we then pull this in our consumer. It's a simple Python app that pulls all these events out and says, sweet, this image is Fortnite from this person, and kind of in this segment. And this image is from Call of Duty, and so over here. And lastly, we store it in MongoDB. This meta information is stored in Mongo for us because we wanted very flexible schemas. We didn't really want to write SQL. We didn't want to create tables. Every day there's a new kind of event that you want to whip up. You just want to be able to put it in, and JSON format kind of enters in, and you can do that. And so we use S3 for image storage. S3 emits events to SQS. We store the meta in Mongo, and we created a UI for labeling tasks. This is our basic classification pipeline. It's kind of how we set it up. And I'll show you a little bit of the UI we created. So one of the things we realized is machine learning and computer vision has actually come a long way. It's really easy to work with. A lot of tools exist. Amazon has a lot of tools. But one thing that was missing was with labeling, with classifying. And so we built this little UI where we could classify 100 images at a time. And the idea was, for the manual tasks, you don't want to go one at a time and go, what event is this? And click over here. You want to say, cool, let me pull this event set. And these are all default labeled. And in this case, I'm showing you, we're trying to train the game of Fortnite. Are you in the game or are you in the lobby? And so all of these images here are basically of the game. And they're all set to game. And I scan through them really quickly. And if it all looks good, I hit submit. If it doesn't look good, I have this little thing on the bottom where I can quickly switch the labels. And different events, you can tag them with different things. And so with the game state, we basically say, cool, is it a game? Is it a lobby? Is it the bus? Are you spectating? And you have a couple of images here or there. You switch them. You hit submit. You can kind of go to the next page. The other thing is you need a bootstrap sometimes. So a new game comes out all the time. Call of Duty just came out. We had no information on Call of Duty. Well, the fun part was we created this little tool that lets you upload a screen capture of the game that you're playing and start your first 100 images. And what that did for us was we get to play a little bit of Call of Duty, run around, shoot some people, and now we have images to classify. You can also use Twitch clips or kind of different sources to where, hey, we want to try this event really quick. How do we quickly bootstrap that? And as a non-engineer, you can do this. And so these are tasks that we got the rest of our team to kind of work on and help us with. And lastly, a little bit of autocomplete helps sometimes. So you got hundreds of different events, typing in and kind of being able to grab some filters. This is really useful for us. And you'll notice the date range. And sometimes you want to go back and classify different things or look back at a different data set, and you can go back and pick a specific time range. And so this was one tool that we ended up building that allowed us to kind of really bootstrap this entire process. All right, so now we have a classified data set, and it's time to train the model. So with the training workflow, first we fetch the training data. We then set aside 20% of the training data for tests. And so you pull 10,000 images. We go to our classification framework, and we say, cool, here's 10,000 images. Let's put aside these 20%. They're all labeled. We know what they mean. And so these are going to be used for an automated test after we train the model. Lastly, we generate the model, and we test against prod. So side by side in prod, we run a test model against the real model, and we decide what's better. And when the next set of images get labeled, we have another set of accuracy that we can determine. And when the accuracy beats the one in production, we're able to kind of deploy that automatically. We ended up picking PyTorch as the tool of choice for creating the model. Our team had very little core competency in computer vision before we started all of this. And we're like, all right, well, what's the fastest way to kind of get us going and what's going to give us good performance? So first we said, okay, PyTorch. We looked around a little bit. We did some research. We tried a couple of different pre-trained models. So VGG16 and ResNet were the two we ended up kind of relying on. It's very fast. Prediction time is awesome. The other thing is you can go from 0 to training in minutes. I mean, it's really easy as an application developer to kind of get this going, get it working. And lastly, it's compatible with SageMaker. We didn't really have to spin up any infrastructure. We can just kind of press a button and get this going, and that's why we ended up going with PyTorch. We also set up a little bit of config that allows us to kind of quickly create different training models. And so one of the key things that you end up doing a lot is you create transformations. And so sometimes you have a giant game screen, but the kill is just right in the middle, and so you want to create this crop region. Or again, the frame might be 1080p. You don't really want to train on a giant frame. So we want to resize it, or you want to swap the axes, or do a couple of things. So we set up a little bit of JSON configuration inside of our pipeline. And then same thing with the models. Like, you want to try different parameters. You want to try a different pre-trained model. We might want to rely on a model that we've worked on before. And so we have the ability to point at different things, and it's kind of what it ended up looking like. And with training, we have a simple Python script that allows us to train the model. And the goal of this script is really create the training set and testing set, perform the transformations, run the config that's set up, and output the model to SageMaker. And so this is kind of what's called the non-automated part, but it's still in a script form, so it feels pretty good. And we test, and this is really kind of what we found was one of the biggest improvements in our workflow was creating this automated test suite. And so from the start, we wanted to make sure that side by side in production or with an automated mechanism, we can create this model and we know it's better. Gamers get angry when things are wrong. So you detect a kill that wasn't there, or you miss a kill, you're going to hear about it, and we heard a lot about it. And so one of the things that we wanted to make sure was whenever we do something, whenever we ship a new model, it's better than the one that's before, and it kind of gets compared. And now that we have the video coming to our servers, we have this model that's trained, it's time to create the real-time detection. And with real-time detection, it was kind of a simple workflow here was we need to know what game the user's playing. And so we rely on our application and our Windows app to be like, what game is open right now? Oh, Fortnite's open. They must be playing Fortnite. We're injected in there. So we kind of load that model in SageMaker and say, this is the one that we're going to test against. We send the images to SageMaker in real time in our pipeline. And our goal was to detect within 250 milliseconds. And so the key was you want the scoreboard to go up very quickly after you get a kill, you get a victory, and something like that happens. And so we wanted to kind of set ourselves up to do this. And the pipeline looked like this. We have the image, we create the transformations and apply them on the image, and we feed that to SageMaker. And then from there, we send that information to the API, and this is our application. And so this entire workflow these 4 steps is basically what we use for real-time detection for the games. And really, the code is super simple with SageMaker. I mean, this is effectively the example code. You create a session on SageMaker using Bebo, and this is Python. You invoke an endpoint, and that endpoint is a specific model that was assigned for that game or that event that we're looking for. And lastly, you read the JSON back, and you send it to the API. And today, we basically take this JSON payload with very minimal operations after this and feed it into our application, and that entire workflow allows us to do that. And so let's look at what the results were for this entire process. So on the client side, we had some hard goals that we wanted to achieve. So we ended up being within about 100 milliseconds of you playing the game to getting out on the network. And we achieved this really kind of working on the GPU on Windows. And we captured the frame, we leave the frame on the GPU, we pass it to the NVIDIA encoder, which is again on the GPU, so you just kind of pass that along. Then after this frame is compressed down into kind of 3,000 or 6,000 bit rate, you then take it off the GPU and send this small payload over the bus, and you can kind of get it off over into the network there. And so we were able to do this in about 100 milliseconds. The next thing was we used less than 5% CPU. We really do this because the hardware encoder allows us to kind of, it's basically free. I mean, the game's not using it, the CPU's not using it, and so this kind of kept our CPU usage low. And we did a lot of work on Direct3D and DirectX to make sure we don't use any of the GPU resources. I mean, we learned a lot along the way of like what you shouldn't be doing, and didn't start at 5%, but that's kind of what we were able to achieve on the end. So same thing on the video server side. We basically had about 100 milliseconds of latency from when we get the image in to when we're sending it off over the network. And this is either going to SageMaker or to S3. We send to SageMaker first, obviously, because we want that real-time detection to happen. And the images aren't really useful in real time, and so we kind of send that secondary. We use very little GPU server side. We rely on the G3 instances on Amazon. These are very large, powerful machines that have the NV encoder and a lot of GPU processing power. So each stream that's coming in uses less than 1% resource. And one of the keys that we wanted to achieve was horizontal scaling, because we're in every region around the world. We have gamers in South America, in Asia, in Europe, and we wanted to make sure we can just take this server and just drop it in anywhere. And if it fills up, we just got to spin up another one right next to it and another one right next to it. And so this is kind of what it ended up looking like server side. On the classification side, we were actually able to do about 10,000 images an hour for training. And honestly, if we put a competition in place, I think we can get it up 2 or 3x than that. The game logs turned into auto labels, and this was honestly one of the best features that we ended up working with, because you would spend some time and look at, okay, when I do this in the game, oh, I see this in the logs. So now we've streamed these logs to our backend, and they're just being matched up against these images automatically, and very quickly you've created this training set away from humans. And lastly, it was easy enough for non-engineers. Our CEO loves labeling, which is kind of a funny task. He's always asking me, hey, can I do something on the technology side? Can I help in any way? And he can't write code. And so this was a way for him to feel like, hey, I'm making the process better. I'm doing something on the technology side without having those skills. And we leveraged kind of different people on our team to help us with that. And we process over 4 million images of Fortnite per day. And we're not even capturing, every single image that we could. This is way more than we need, but we were happy that we were able to process millions of images a day through the classification pipeline. On the detection side, so we're able to detect an event within 50 milliseconds. And so you can kind of add this up and say, all right, we got 100 milliseconds on the client, we got 50 or 100 milliseconds on the ping time, another 100 on the server side, and 50 for prediction. So we're under half a second to kind of get that information back to the client. And our goal initially was 1 second end to end, and maybe up to 2 seconds if we wanted to be a little slow. And we're very happy that we were kind of well within that range. On SageMaker, we use P2X largest. We're able to detect 900 images per second. Since we're taking 1 second of video and taking 1 frame of it, we can reuse, in a given second, we can reuse many different streams that are coming in on the same P2 instance. And lastly, with 50,000 images, we're basically able to get to 100%. We don't like saying 100% because if you miss one, then somebody's going to be like, hey, what happened? But we see very few false positives, very few missed events. Mostly if it's a missed event, something got corrupted along the way, and it wasn't a prediction problem. It was a pipeline problem, or the video stream ended, or their bandwidth died, or it's things like that, and not actually on the machine learning and computer vision side. And on the accuracy, here's a little graph that kind of shows you how quickly you get to effectively 100%. And you'll notice it says 100% on the left because it rounded the 99.999 up to 100, so we'll trust the graph here. With 2,000 images, we're over 90%. And this was a more complicated event. This was detecting the game itself. If we did simple events like a kill or a victory, with the 100 images, you were already at the 90% range. And so, in 5 hours, we can take an event from kind of 0 to done. And that was kind of the cool part about this entire project was we were able to say, cool, here's the game, here's where it starts, here's the thing that I want. 5 hours later, you have this thing that you can trust, you can deploy to prod, and it's excellent. And so in conclusion for this project, we were able to create 10 plus events in Fortnite. We were able to capture the health, where you are on the map, kills, victories, different parts of the puzzle that existed for the game. We expanded into multiple games. So Call of Duty came out. We were able to train events in Call of Duty. PUBG is another kind of popular game right now. And we're looking at games like League of Legends, Overwatch, and kind of different games. And we were able to expand into those. And lastly, adding new events required zero code. That was the entire objective at the start. You have a small team at a startup. You take a project. You don't want to work on this forever. You have too many things to do already. And you don't want to spend next game's going to come out next month. We're going to spend that whole month on the next game. And we just keep doing that cycle, and we're like, nope. We're going to basically create this system. We're going to deploy it out. We're going to have the rest of the company help us. And Now when a new game comes out, we capture that spot, we upload that first video, we start labeling, we have people play the game, we get the next thing going, and didn't have to write a line of code, didn't have to deploy to production, didn't have to do anything. And so I'm going to show you kind of what it looks like. And the video is a little choppy. There's something going on with this machine over here, but you'll get a sense of kind of what it looks like in action. So excuse the crazy frames, but basically here's a 13-year-old streamer. He's pretty famous. He gets about 3,000 or 4,000 concurrents on Twitch. And right at the start of this clip, he basically loses 41 health, and that's what our engine detects. And then as he goes along, and sorry about the choppiness of the video here, he'll kind of run around for a little bit, and he'll basically kill this guy right here. And right when this event pops up, our engine detects that this event was detected and the kill was there. And then right after that, he wins the game. And he says, sweet, victory royale, so victory is detected. Then the kill's detected. And you'll notice on the bottom left over there, that's our UI that goes on top of these streams. And the score goes up in real time. And this is a clip from a tournament from a couple months ago where, people are playing competitively in their rooms and enjoying kind of this competition. And on the right side, you can see the leaderboard of all the different teams and where they are in real time. And so a user in Europe kills somebody, it ticks up on a user in the United States, and the end-to-end is about 2 seconds. And so that's kind of the fun part about building this. I had some general thoughts around kind of machine learning and computer vision. So our team had very little core competency around either of these technologies. I mean, we've read about it, we've tried the examples, but really very little production code. But it's gotten so much easier in the last couple of years to take these tools and say, you know what, we can use machine learning on this. We can kind of make that happen. And really, it went from like a research problem to an application engineer problem. And within a couple of months, we were able to go from 0 to in production with hundreds of thousands of gamers using us and playing with us. And again, we started with not that much knowledge. And you read things online, you read a blog post, oh, I know this. You actually don't. You try your first line of code, you go through it a little bit, and surprisingly, it was really easy to get going, and the tools were there. And actually, we spent most of our energy on a little bit of UI to help us with classifying and labeling, not the hard stuff, the things that you kind of do normally. And it's kind of a unique tool. Like, as an engineer, I think about, I got this tool belt, got a hammer, I got a screwdriver, I got Python, Node, I got all these languages. But now you got this thing that's like, it could take any shape, it could take any form, it can morph, and that's what I think of machine learning and computer vision. And now I got that in my tool belt as an application developer, and we can use it to solve kind of a variety of problems. And it comes up more often now that we've done this project. We go, hey, we can use machine learning to solve this. And it doesn't feel like this far-fetched problem that research guys are doing, or it's super hard. It's gone kind of to the next tier, and it's come up a layer in the stack. We're a big proponent of open source. We pretty much use a lot of open source in our stack. As a team of 10, you have no choice. You can't build anything, nor should we. Really what we want to do is leverage the work that a lot of people are doing and collaborate with the community. So a lot of the projects that I talked about are on our GitHub over here. The 3 projects are Yeller, which is a UI for classification and that framework. The Game Capture, which is a wrapper over the OBS Game Capture, and it plugs into GStreamer. And lastly, Bran, which is the real-time detection engine, also wrapped in GStreamer. And so we really want to kind of collaborate and work with a lot of the developers around the world. And we've hired a couple of the developers that have worked on our open source projects. And honestly, in my entire life, I feel like I can't repay open source enough. Every day I'm using something that somebody else spent time on, and I don't even know who that person is. And the philosophy of our company is we want to do the same thing. And thank you guys for listening to me talk about machine learning today and computer vision. If you have any questions or comments, feel free to reach out to me on Twitter or email, or you can ask here as well. Thank you. We have a lot of Game of Thrones references, so good catch. There you go. You can see everything, right?
So just so I understand, so like people using your product, they might be playing games that are really not related to each other, or they're playing in competitions that are not related to each other, and you're watching them play, and they're getting on a leaderboard.
Correct. So like I'm playing a game of Fortnite. Me and my duo are playing over here. You and your duo are playing over there. We're competing on the leaderboard in real time. And so it's kind of this asynchronous, synchronous real-time competition. And we found that it allows people to play in their own bedroom, play on their own time. But then you get this feeling of competition and kind of this social experience that you don't get by playing the game the normal way. In the normal way, me and you team up, we play against a stranger. And what we wanted to do was kind of collect these guys together. And with high schools and colleges, like they really enjoy this. And it's a way to kind of get that same feeling that I grew up with, recreational sports, but in esports. Yeah. So we timestamp the logs as they come in. So some game logs have timestamps there. Sometimes you can trust them and sometimes you can't. I mean, honestly, on Windows, you can't trust time. What we end up doing is we get UTC time on the client. We do that work when our app first loads up. The logs are streaming in real time, and every game is kind of different. So you spend a little bit of time looking at the game logs and say, is it real time? Is it delayed? If they're delayed, we can't use them. If they're in real time, like as the event is happening in the game, then we're able to use them. And so with Fortnite, we were able to use a couple of things. Entering the game and exiting the game were real time, but everything else wasn't. Correct. So we used kind of simple CV, so template matching or color detection to make sure. So like if you notice the kill text, it's like eliminated, it's white, and then there's like a red player name. And so we have kind of what I call simple CV where, hey, are there white, what's the white percentage here and what's the red percentage here? As another mechanism of testing and saying, was this accurate or not? And so there's a lot of other pieces in play to allow us to kind of create that accuracy, but, what do you mean? Sorry, expand on that. So one of the fun events that we created was we watched the map, where you are in the game. And in one of our competitions, we had this thing where if you're in Tilted Towers, which is a specific spot in Fortnite, you're going to get 2 times the points. And so this competition, nobody else has created this. The game could create it, but we were able to kind of whip this up and say, right now, if you drop here, you're going to get double the points in this competition. So our the entire tournament, they're just flooding one spot. And so that was kind of some of the fun stuff that we were able to do. And really, anything the user sees, we're able to see. So how many people left? If you get into the top 10, you might get a point in the competition. If you win, you might get 20 points. But so that was some different events. Yeah, and it's the same thing. It's just, honestly, it was just labels. So you have this map, and you have this kind of name that comes up there. And so we crop this region of the map. OK, it's tilted, so we label it tilted. There's 10 spots on the map. And so the same UI to classify, you have 10 different labels, and you say, oh, I want to train tilted today. So I go through and find them all, and after I get about 1,000 images, the next images are pretty much accurate. And we say, OK, these are roughly the images that should be there, and then it just gets better and better very quickly. I think you had a question over here. Yeah, and so Fortnite is actually abnormal in gaming. They release a lot of updates, and so we have to watch it pretty regularly. Usually we get yelled at early in the morning when it happens, or you stay up till 3 a.m., the update happens, you want to see what's there. A lot of times there is no API, so we kind of don't have a choice. It's like nothing or live with that, and to be honest, we mostly don't have to make too many changes. There was one big change where they changed the victory text and the eliminated text. They added kind of this bold layer around it. The eliminated actually worked fairly well still, but within an hour, we were back to kind of where we needed to be. The victory was totally different, so it took a little bit more time, and we actually get fewer images for victories, so that took a little bit longer. It's a tricky question. So I think we'll probably throw a little bit of engineering resource at it. And honestly, sometimes if it's as simple as just a new label, it'll be non-engineering resources. And I think that was the key is we wanted to invest early on so that we're not, like, I don't need dedicated engineers just doing this. I have plenty of other problems, so got to focus on those. And so a new update comes out, talk to the CEO, talk to the marketing guy. Hey, you guys want to label some images? All right, let's do this.
One of the things that I've noticed is you watch a lot of YouTube and kind of get tips and tricks of double pumping.
Yeah. Good reference, by the way.
So one of the things I've noticed, one of the things I did when I saw this
Yeah, and so the way we process things, we actually get all of that information. We don't surface it to the users, and there are a couple companies that are in our space that have been kind of doing that. Some of the game publishers don't like it, and so we've kind of, our job is to create this competition. I totally believe that there's the same part in there, and I know esports teams, like the pros, are using this kind of software for very specific, like, hey, this is what you did wrong in this game right now, and for them it's really serious, But yeah, exactly, the same technology that we're doing, the same pieces could be used kind of for a different application. Yeah, and so you've seen that iPhone demo, right, where they're kind of showing that, and that's kind of one of the exciting parts about open source is we're seeing people use video and tracking different things. Hockey is a very interesting sport, or soccer, where if you can get a good camera view of the entire, in the entire arena or the entire field, you can kind of spot these pieces and moving around. And I know in soccer, you'll notice the tablets on the sidelines. The coaches have a health meter that basically will tell them, hey, this guy's fatigued. He's not moving as fast. He's not accelerating as fast. And so really, I mean, that's kind of the exciting part about all this technology moving up the stack to application developers. Like, it just opens up what can happen. And I think Little League Baseball, high school sports, like, you're going to be able to do all of this kind of across the board. So. So we went from kind of 0 to production in less than 2 months. Yeah, it's surprisingly easy now. I mean, a combination of what you get with Amazon and the tools I think TensorFlow to PyTorch was one of the biggest changes for me, at least, in just looking at it. TensorFlow, powerful, lots of knobs, sometimes too many. PyTorch, here's 3 lines, get going. And the pre-trained models and the work that all the researchers are doing behind the scenes and kind of all of that last 10 years of machine learning, like it's all coming together where a couple of scripts, a couple of open source libraries, and you have the same technology that everybody else does. And I think technology kind of democratizes over time, and I think that's where we are with computer vision and machine learning. And so we've, like I said, read a lot of blog posts, read a lot of white papers, had very little production experience, and you go into it, you're like, it's going to be easy. You kind of trick yourself into it. It actually wasn't too bad. And, so. Yeah, and so Fortnite is pretty interesting because they focused on kind of the top, right? So a lot of these game publishers, they want to own the top of the competition, the esports, the main prize, the millions of dollars. And actually, we don't care about that. We're not caring about the professionals. What we want to do is the people who enjoy the game and want to play this recreationally, we want them to play more and play in different ways. And so far, the responses have been good. We'll see over time kind of what happens, and maybe some game publishers are not friendly to us, and we'll kind of figure that out. But I think once you build a big enough mass of gamers that want your product, you're really supplementing the game and kind of improving. And the good thing is there are a lot of games. So if we do end up in a scenario where one of the publishers says, hey, we don't want you doing this, we don't like this, we can kind of still focus on the other games. And some games like League of Legends, they have 70 million monthly players. Fortnite has 125 million monthly players. And so you kind of have a variety across the board for us to kind of go after. And that's kind of how we've approached it now. So we'll be going to Xbox and mobile pretty soon. And so that's going to be a fun, interesting project to kind of grab the information off of it. With Xbox, it's really easy because it's a universal Windows platform. So a lot of the code that we're writing on Windows will kind of port over to that. On Android, it's really easy to grab a screen capture. It's just an API that Android offers. iPhone is going to be very fun. So we'll kind of see how that goes. Yeah, no, that's a good question. Within our app, we actually allow people to watch the games that are going live. So we actually use the video streams for that purpose as well. So it's not just for detecting events. We actually use it within our application. Also, images are actually kind of big in comparison to video. The keyframe is the biggest part of the video. We run keyframes every 2 seconds. Yeah.
I did a thing where we were doing image capture many years ago. What we were doing was basically just taking XORs. And so if you had like maps of where this information was that needed to go, you could basically just ignore everything else and just take that.
Yeah,
And then just do like a run limited to black and basically end up with a very small image that you would take with you every time.
yeah, no, that's a great question. We thought about that as well. So taking the map, taking this piece and cropping it out and kind of putting it together. One thing we ran into was gamers do funny things like they play on stretched resolution. And so stretched with a game like Fortnite moves the UI into non-predictable spots. And that's actually why we went with machine learning. So like when we first started, the first day was like, oh, we'll use template matching. This is what the victory looks like, super easy. We put it in, I played 10 times, oh great, this all works. We go to users and they're like, dude, this is not doing anything. We're like, why? Well, I'm playing on this stretch resolution. My monitor is this thing, or I have that. And I'm like, oh man, all right, well, now we got to think of the problem slightly differently. And so that was kind of fun. Awesome, guys. Thank you.